And this should be the last video, hopefully. Okay, we're back to solving rational equations. So we have restrictions. X is not allowed to be a positive 1 here and a negative 4 here. It can be anything but that. I don't like working with fractions. I'm going to get rid of it by multiplying by our least common denominator, or least common multiple. The way we find that is we write down our first denominator. Go to your next denominator, and you need to list it as well. Now, we're going to multiply by everything we see, or multiply our least common multiple by everything we see. So here we're going to multiply this times the 4. We're going to multiply this one by that. And we're going to multiply this one by that. Okay. So this first one is going to be the hardest. I'm just going to go ahead and multiply these two. This really gives us w squared plus 3w minus 4. But I'm multiplying that whole thing by 4. So 4 times w squared is 4w squared. Then that one was probably the hardest one there, see, because what I did was I multiplied these two and got this. Now I'm going to multiply it times that 4, and that's where I'm getting 4w squared plus 12w minus 16. This cancels, so I'm saying 7 times w and 7 times 4. That gives me 7w plus 28 equals, these cancel. I'm going to distribute the 3. 3w minus 3. Okay. I'm going to combine my like terms before I start moving and everything. I'm going to have 4w squared, 12w and 7w. That's bad. There we go. I started to circle it. Okay, 12w and 7w, that's going to give us 19w. 16 and 28 gives us 12. Equals 3w minus 3. Now, because I have a w squared, I've got to take everything over to one side, set it equal to 0. So I'm going to take this over here by subtracting it. I gotta take the 3 over to the other side by adding it. So I have 4w squared plus 16w plus 15 equals 0. Now what you have to do is, rather, because we can't do square root property, okay, we can use quadratic, or if it would factor, we'll factor it. It will factor, so I don't care what you use. It doesn't really matter to me. I'm pretty sure it'll factor. I'm going to try factoring it. Let's try 2w and 2w. Because the only way to get 4w is rather 4w and w, or 2w and 2w, and I'm always going to tell you to use the 2w. Okay, to get 15, 1 and 15, or 3 and 5, I'm going to tell you to use the 3 and the 5. Okay, they both have to be the same, which means they're both going to be positive. So I'm going to put plus 5 here, plus 3 here. Let's see if that gives it to us. This here gives me 6w plus 10w is 16w. Oh, thank goodness I don't have to use that quadratic formula. Take both of these, set it equal to 0. I'm going to subtract 5, and I get 2w equals negative 5. Divide by 2. W equals negative 5 halves. Here I'm going to subtract 3. And I get, I don't know why I showed that work, but I didn't on the first one. Divide by 2, and W equals -3/2. Those are both okay because it wasn't our restrictions. You can use your calculator, store these, plug it in, see if it works, and if it works, fantastic. I just don't have my calculator to even show you that. So, let's see, the next one. Okay, the next one here, we are going to do our restrictions first. Our restrictions, W cannot equal 3, and they cannot equal 2. Okay, the least common multiple is going to be the W minus 3. Let me put it up here. I'm going to try to get all this working and don't give you much room. I'm going to list my first one of W minus 3. I'm going to list my next one because I don't have it, which is W minus 2. Multiply everything you see by those. Don't forget to do that with the 1. And be careful, that 1's negative. So I may do this a little bit different than usual. I'll try not to skip a step. Okay, so. Alright, when I go to multiply, these cancel. So here, I'm going to put it right here. I have W minus 2 times W minus 4. Okay? Now, right here, be careful. This is a -1. There's a lot of different ways you can work this problem. I'm just going to write it out like this. -1 times W minus 3, W minus 2. And then here, those cancel. Ooh. So equals, I don't have enough room. Try to make enough room. W minus 6, W minus 3. And that's really small there, guys. Okay. This one right here is the one that I think you might have trouble with. Okay. Now, I have a tendency to multiply these two together because I can do it in my head and then multiply by the -1. Okay. But you might want to distribute the -1 to write the W minus 3 and then multiply it. It doesn't really matter. But the way I'm going to do it is I am going to multiply, first of all, I'm going to multiply those two out using FOIL. I'm going to get W squared, -4W, -2W gives you -6W. -2 times 4 gives us +8. Okay. Now, I think I have 2 of these. I'm going to multiply these two. Okay. Now, I'm going to bring down this -1. I'm just not dealing with it. I'm going to multiply these two right now. Okay. And then I'll distribute that -1. But you can do it however you want. W times W is W squared. Outsides is -2W. Inside's -3W, which gives us -5W. -3 times 2 is +6. And now I'm going to multiply. Then I have equals. I'm going to multiply those. That gives us W squared. -3W, -6W is -9W. -6 times 3 is positive. -3 times. -6 times the -3 gives us +18. Okay. Now, what happens to everything else? What happens to all the signs when it follows a minus sign or a -1? It changes. I'll move this over a little bit. So I'm going to rewrite this. When I distribute this -1, it changes all those signs. So I get negative w squared positive 5w minus 6 equals w squared minus 9w plus 18. On this side, those cancel. Negative 6w and 5w give us negative w. 8 negative 6 gives us 2. Equals w squared minus 9w plus 18. Okay. Because I have a w squared, I have to get one side equal to 0. So that means I'm going to take this over here by adding it. I'm going to take the -2 or the 2 over there by subtracting it. And this side gives me 0. Over here I get w squared minus 8w plus 16. Okay, I know that this factors. W minus 4 times w minus 4, or the quantity of w minus 4 squared. So I only have to do it one time. So w is equal to a positive 4. And that's okay. If it hadn't been, I would have had to mark it out and put no solution. Okay. Square root. Got to get the radical by itself. It is. Once it's by itself, to undo it, you square it. If I square that side, I got to square this side. So I get w. Oh no, I get x. So used to the last two problems used a w. I get x equals 16. If I was to check it, square root of 16 gives us 4. And it would only give us a positive 4 because the square root symbol was already there. We didn't put it in there. So this one checked. So that's right. Right here, I've got to get the square root by itself. I've got to get 3 to the other side by adding it. I get the square root of u minus 13 equals 5. To get rid of the square root, I square it. If I square that side, I square this side. So over here, I have u minus 13 equals 25. I'm going to add 13 to both sides. U equals 38. You want to check these because it may end up to be an extraneous solution. So let's check it. We're going to plug it into, for u, we're going to have 38 minus 13. Then we're going to subtract 3 and hopefully we end up with 2. Well, underneath here we get the square root of 25. Because this radical was already there, this symbol, it was in the problem to begin with, we only take the positive 5. And so 5 minus 3 gives us 2 equals 2, so it checked out. Okay. That was 31, right? Yeah. All right. Last 4 problems. Whew. Okay. Inequality. On this test, we're not going to test you on interval notation, so we can just do the inequality. I'm going to add 7 to both sides, and I get 18 is less than or equal to 3u. I'm going to divide by 3. Because I'm dividing by a positive, my symbol is this inequality stays. So I'm going to get 6 is less than or equal to x. I will take that, okay? But I like my x to come first. I also could read this as x is greater than 6. So basically, if I switch these, I switch my symbol, okay? You didn't have to. If I was testing you on set builder notation, remember, you just do this. I'm not. Okay. Interval notation, you got 6. Closed circle because it's equal. And it's everything to the right. Because this is saying 6 is less than that, so that's how it would be. Interval notation, bracket, because it's a filled in circle, and it goes to infinity. Okay? But on this test, we don't tell you to do that. We're just going to do this. Okay? Right here, I'm going to distribute the 2. I get 10W plus 16 is greater than 3W plus 2. Oh, by the way, remember, if I divide by a negative, if this was negative, this symbol would have changed, but it wasn't. So I'm going to take the 3W over here by subtracting it. I get 7W plus 16 is greater than 2. I'm going to subtract 16, and I get 7W is greater than negative 14. Divide by 7. Because this is a positive 7, my inequality stays. So it's W is greater than negative 2. That means any number I pick to check into this equation, if it's greater than negative 2, it'll make this a true statement. Like if I'd pick 0, because 0 is greater than negative 2. If I plugged in 0 right here, I'd get 0 plus 8 is 8 times, I'd get 16. If I plug in 0 here, this gives me 0 plus 2 is 2. 16 is greater than 2, so it checked. Okay, I don't like the fractions. I'm going to get rid of the fractions by multiplying everything by 8. Everything, don't forget the 2 as well. You guys may do negative 8 times 3 is 24, divided by 2 is 12. Y. I go 2 goes into 8 4 times. 4 times negative 3 is negative 12y. Negative 2 times 8 is negative 16. Is less than or equal to? You might do 72 divided by 2 is 36y. I do this. 2 goes into 8 4 times. 4 times 9 gives us 36. And here you might do 56 divided by 6 is 7. I just do my 8's cancel and I get 7. Okay, I'm going to subtract 36y. So I'm going to take this over here. I'm going to get negative 48y minus 16 is less than or equal to 7. Take 16 over there. I'm going to add it. Negative 48y is less than or equal to 23. I'm going to divide by negative 48. Oops, I need to move that up. There we go. And I get y. Because I'm dividing by a negative, that number is negative. Okay? My inequality switches. So it was a less than, it becomes a greater than. It has nothing to do with my answer. It just has to do with because we're dividing by a negative. And this I'm just going to bring down as negative 23 over 48. It doesn't really matter where that negative goes. It goes with the whole fraction because a positive divided by a negative is a negative. Okay. And got 2 more. Thought I only had 1. Okay, remember, the only way it can be these are your U's disappear. If it's a true statement, it's all reals. False statement, no solution. Okay, so here, I'm going to get negative 3u minus 12 plus 27 is greater than 15 minus 3u. Oh, my hand's hurting. Okay. I get negative 3u. I'm going to combine these two to get plus 15 is greater than 15 minus 3u. And at this point you might go, oh, they're the same, but you may not notice it. And I'm going to keep going. I'm going to take the 3u over here by adding it. Went back to changing my pens. And I get this statement here. 15 is greater than 15. The problem with that is they're equal. So this is a false statement. So if it's false, it's no solution. Now, just so you know, had this been an equal sign, greater than or equal to, it then would have been a true statement, so it would have been all reals. But it wasn't. Okay, they didn't have greater than or equal to. So this is no solution. And the B one, 14y plus 12 is less than or equal to 14y plus 11. Okay, so I'm going to subtract 14y. And we get 12 is less than or equal to 11. Again, that is a false statement. Okay? If it is a false statement, it is going to be a no solution. Okay? So this again is a no solution. I'm double checking up here to make sure I did it, because I would have thought they would have had one of them as all reals, but it really depends on which copy of this review that I print off. You never know. So I'm checking it up there. Okay, I think everything is right, unless I'm just double checking. I just was figuring it would be, yep, that one's right. Okay. Alrighty, that's it.